All right. So question one asks about a researcher analyzing monthly sales data from these years. And we're not told exactly the specification of the regression model, but we're told it's just for quarter dummy variables. And then we're asked to interpret one of the variables. So here, there's actually two ways of doing this. And from this question, it's not actually clear which of the two models we're using. But the one we've used most commonly in the class looks like this, where we have some intercept term. Then we have beta 1 times, so this would be Q1, or I guess this would be Q2, plus beta 2 times Q3 plus beta 3 times Q4. So we have, a base intercept term for the first quarter. And then we have one dummy variable for each of the remainder. So the way this would look, we would have, a vertical intercept beta 0, and then each of the others would be sort of some additional component, so beta 1 on top of these. We're not told that there's some, x variable here, so all we're doing is looking at these intercept terms. Okay, so this is one way of doing it. There's actually another way of writing this, which would be beta, we could do beta 0 times Q1 plus beta 1 times Q2, and so on. So in this case, these interpretations would actually be different. But the one we've done the most is this one. So I'm actually going to focus just on this one. Okay, so nice. So the first question is the first option is A, the average sales in Q3 across all 3 years. Well, actually, in this model I just crossed out, that would be the interpretation. So there will be some partial credit for this question, or for this option. B is the one we've dealt with the most, which is the difference in sales between the two quarters. And it's not actually fully specifying what this sort of means in this case, but this is the right answer. It's the difference in the the average sales between each of the quarters. And then the C is just not correct. Percent growth, we haven't said anything about percentage. And then D, the total sales in Q3 compared to the entire year. So this isn't, that's not right either, because we're not actually comparing it to the entire year. Okay, so nice. So question 2, in the first difference model for time series data, what's being transformed? Well, when we have time series data, when we're doing a transformation, if we're looking at first differences, we have YT, so the current period, we have YT minus 1, the previous period, and this gives us the change in the Y variable across the two periods. So in this case, this would be the transformation. And then, so let's just see which one of these options corresponds. So A, each observation is subtracted from the sample mean, so that's not right. We're not actually comparing to the sample mean. B, each observation is divided by the standard deviation. So again, we're not dividing by a standard deviation. That actually looks a lot like a t distribution. C, each observation is subtracted from its previous period value. So nice, that would be the thing we did here. And then D, each observation is compared to a reference category. So the answer here is C. Question 3, which of the following models would best capture how the effect of education on income differs between men and women? So if I were just writing this question out with a regression equation, I would write it as income. We then have a beta 0, which would capture some base, wages for those with a 0 value in education. And then we would have, let's just say a beta 1 times EDU. So then this is, the base income education relationship. And then we'd have a beta 2, which is edu times some gender categories. The one we've used in the class is male. So this is just a binary indicator variable for being male. So this gives us the same intercept by group. And then we have one coefficient, so one slope returns to education for the base group, which in this case is not male. And then we'd have one which is an additional coefficient for those who are male. So this would be the model I would write down. And so let's just go through and check which one gets closest. So A, we have income is equal to beta of 0 times education, nice, times male. So this is one we've done, but this doesn't get us at differences in the returns to education, which is what this question is asking for. So this isn't the right model. B is income is equal to beta 0 plus beta 1 times education, plus we have a new intercept term, so 2 intercepts. And then here we do have a differential impact of education on earnings. And then C, we have income is equal to this. Well, we're introducing experience, which is not part of the question. So this isn't right. And then here, this is the same as A, looks like, except we're just taking a log. So the closest one, this isn't necessarily the one I would first start with to answer this question, but this does give us differential returns to education because we've conditioned on our dummy variable. So an interaction effect. Q4, in a regression model with a time variable and quarterly binary indicator variables, so we're given this thing, the beta 1 represents what? All right, so let's look at these options. So intuitively for me, when I'm seeing this, I'm seeing it's really about the trend in sales, or log sales in this case. So it's giving us like the slope, ln sales, it's giving us like the slope. So it's going to look like this. So this is basically, we interpret this as like the trend in the y variable. Okay, so A, and in this case, we're actually controlling for a bunch of other variables. So it's after we've accounted for seasonal differences, what's the trend? So A, the seasonal effect on sales. Well, in some sense that might be true. B is maybe a little closer, the quarterly growth rate of sales, except here it's not about a growth rate. So we can actually rule this one out because this is talking about growth rates. If it were to say the quarterly change in, the average quarterly change in sales, log sales, that would be a reasonable interpretation of beta 1. C, the average sales level in the base period. So this would actually be beta 0. And then D, the underlying trend in sales after accounting for seasonality. So this looks the most correct to me. Some of these are, in the ballpark of like doing something like what this beta 1 is meant to do. But D is the closest one. All right, so question 5, consider the following regression output for a model examining the relationship between GDP growth rate and unemployment rate changes. And then we're saying the outcome variable is this. So that's our y variable. Nice. So it's the percent change in something in GDP. Okay, so interpret the intercept beta 0 in this model. So the intercept, I'm just going to write the model out. Actually, often this is helpful for me. So that's like, percent change in GDP is equal to a beta 0 plus delta unemployment plus epsilon. All right, so beta 0 in this model is just, we can think of this as just the base growth rate with essentially zero unemployment. So we'd write this as the growth rate of GDP with no unemployment. Okay. And then the second part of this question is interpret the coefficient for delta unemployment, beta 1. So that's this thing. Well, yeah, maybe you should include is 2.15. So this is like, the actual growth rate that we've estimated. So interpret the coefficient for delta unemployment, beta 1. So this is, we could write this as every increase in unemployment is associated with a 0.73 decline in GDP growth rate. Okay, so terrible sentence, also terrible spelling, but that conveys the point. Okay, so then explain why a first difference model might be preferred over a levels model in this analysis. So in this case, a first difference model, like we've done here, actually gets rid of some of the problems of autocorrelation, and that's really the main reason in this case. So it reduces, because it doesn't actually eliminate the problem of autocorrelation. Nice. So that's, we've talked a lot about this. All right, so question 6, the following model examines the effect of education on wages with an education and gender interaction. So we have this interaction here, and then we also have these two terms. So what does beta 1 represent in this model? So this is the returns to education, because it's every additional year of education, how does that impact wages? And then the second question is, what does beta 3 represent in this model? So this is like the additional returns to education for those coded as male. So this is the additional returns to education for those with male equals 1. Okay, so nice. So then for this last one, if beta 1 is equal to this, beta 2 is equal to this, beta 3 is equal to this, calculate the percentage increase in wages associated with one additional year of education for women and men. So there's actually maybe a bit of a problem with this question. This is actually, I would probably change some of this wording. So the way I would interpret this, what we're actually trying to say is that we want to know, like, one additional year, how does that translate into log wages? So I'm not going to ask directly for an interpretation of log wages, but what we can do here is talk about how one additional year of education impacts the log wages. So we could say one additional year of education is associated. Oh my gosh, this is the worst spelling day I've had in a while. That says associated. We'll just all believe. It's associated with so beta 1, so it's the base education rate, base returns to education, plus for those with 1 equals male, we have this additional piece. So this is with beta 1 increase in wages for female, and beta 1 plus beta 3 for male. Okay, my handwriting has gotten so bad. Deepest apologies. Okay, but that's roughly how we would interpret this. And if you wanted to include numbers, you could. I've sort of run out of space, but this is generally sort of what this question is asking for. Okay, so question 7, for each of the following scenarios, specify the appropriate model equation. Include all variables and parameters. So A, analyze, and this is sort of intended as, at least in this mini-exam demo, as a bit of a bonus question. These are on the harder side. For each of the following scenarios, specify the appropriate model equation. So the first one is analyze the impact of monthly temperature on energy consumption with fixed effects for different cities. So we could write this out as, so we have on, so we know the y variable is energy consumption. So we could write this as energy is equal to some beta 0 plus beta 1 times temp plus, and then we want fixed effects for different countries. So I'm just going to write this as in sort of Python notation, but you could write this however you like. So this is, controlling for each of these cities with a fixed effect. And then we have our epsilon term. Nice. And then B, we're examining how changes in inflation rates affect changes in unemployment rates using time series data. So we want changes in unemployment as the outcome variable, because we're asking about the effect on. And then we have a beta 0 plus a beta 1 times inflation rates. So we're asking about changes here. So this is changes in inflation. And then anything else here doesn't look like. So that would be the end. All right. So this is a good example of what you might expect to see on a mini exam. This is on the longer side. There's a lot going on here, but these are kind of the ballpark kinds of questions I will ask. See you in the next one.